This video is designed to accompany the protocol Panel Optimization for High-Dimensional Immunophenotyping Assays using Full Spectrum Flow Cytometry. This is video 1, which follows Basic Protocol 1, Preparation and Evaluation of Optimal Spectral Reference Controls. So I'm working here in Cytek's Spectral Flow software, and I've got all of my single-stained cells and single-stained beads which I have acquired at the cytometer. And now we're going to go and evaluate all of these controls. So the first thing I have to do is check that the acquisition criteria that should have been followed when you were at the instrument has in fact been followed, and all of this data is actually usable. So to start off with, I'm going to take a quick look at the scatter profile of both my cells and my beads to make sure everything is on scale, relatively clean, and able to be gated on. So I've selected my unstained tube here, and looking at the scatter profile, everything is looking pretty good. I can see my cells of interest nicely on scale. This is a T-cell panel, so I'm interested in lymphocytes, and these are just some PBMCs. So here I have my lymphocyte population sitting nicely in the middle here, and I can easily gate on this. I can separate it easily from the debris in the sample, so no trouble there. I also want to check that the forward scatter area scaling factor has been optimized. So to check this, I can leave forward scatter area on the x-axis and change the y-axis to forward scatter height. And what I'm looking for is a nice 45-degree angle with the main population of cells sitting in this diagonal from bottom left to top right. And that's what I see. Everything's nicely optimized, and so I can easily see where my doublets will sit, falling down here to the right. So I know I can easily gate on singlets to remove false positive events. So bringing us back to side scatter here, I'm also going to take a look at one of my bead samples to make sure that my beads are on scale as well. And yes, they are. They look good. So I'm happy with the scatter setup. The next thing to do is to take a look at the fluorescence settings that have been used to make sure that these were acquired at the right kind of settings. So what I'm going to do is right click on one of my tubes, come to Edit Properties, and under Instrument Settings you'll find all of the fluorescent detector gains that we use to record that sample. I'm going to take note of a few here, try and remember the numbers, so 600, 200, 400, 800. And then I'm going to take a look at a QC report, which was run on the morning that this sample was acquired. So here I have the QC report from the QC that was run on the same day as these samples. And what I'm interested in is this gain column here, as this will tell us roughly what the correct gains were for that detector of that day. Now, these will never be identical to the Cytek assay settings, but as long as they're in the same ballpark, then we know that everything is okay and no major changes have been made, which could impact our data. So, numbers here, 600, 200, 400, 800, we're in the right ballpark, so that's great. And it's always a good idea to check just a few off of every laser to make sure that no significant changes have been made, which could have significant impacts on your data. Now that we've verified that the Cytek assay settings we used here, we just want to double check that all the tubes in the experiment were recorded under the same settings. And so again, just remembering those top few numbers, and then if I come down to another tube, I should see those same numbers, which I do, so that's great. So I'm confident that everything has been acquired at the correct settings, everything is able to be gated on and clean, so we can move forward with this data. So the next thing to check is that our unstained is in fact unstained. So the easiest way to do that is to come back to our raw worksheet so we can take a look at a spectral plot. If I draw the spectral plot here and I make it show just P1, as I'm only interested in lymphocytes. Here we go, we can see our spectral signature of our unstained sample. So you can see that I do have some decent fluorescence in the UV, the violet and the blue, and a mild amount in the yellow-green. This is not contaminating fluorescence, this is just autofluorescence. What I'm actually looking for is very distinct signatures of known dyes. I can check the other cells in the sample to make sure that they aren't contaminated either, but everything looks clean. I'm just seeing autofluorescence, so my unstained is in fact unstained. Okay, to take a look at these controls, we're actually going to do that in the Unmixing wizard. So I'll click Unmix. And then what I'm going to do is change every single control in this list, except for my viability, to be on beads. Okay, I've selected all beads. Now we'll click Next. And now we need to set our gates and check our spectral signatures. So to start off with our scatter gate, you want to be precise with your P1 gate here, and you only want to set it on your single beads. We don't want to be including the full bead population, just the clean single beads, which will be the main bulk of the population. When it comes to setting our positive and negative gates, I always just get the highest median fluorescence intensity events with beads because the peaks are so narrow. So long as your preparation has been good, you can take the whole peak, but I prefer just to take that top section. We then need to go through and QC all of our spectral signatures. So the first thing to check is that the peak channel actually is the peak channel. So usually the peak channel is denoted by these bars, but you can double check in Cytometry Spectrum Viewer on their website to see which channel should be the peak channel and make sure that your dye is actually peaking there. The next thing to check is that the full spectral signature matches that what we would expect. So you can use, again, the Cytometry Spectrum Viewer or their published fluorophore guidelines or any historical data that you have to make sure that this signature is exactly as you would expect and there's no contaminating peaks or anything weird going on. You also want to make sure that each channel has a nice tight population of events. You're not seeing big smears which could indicate contamination or something else going on that needs to be investigated. Really, each channel should have a nice tight box showing that there's just a single signature in there. We also want to be sure that our fluorescence signal is on scale. So everything should be below 4 × 10⁶, and if it's not, then you need to consider retitrating your dyes or potentially changing the settings if absolutely necessary. So all of my signals are on scale. And the last thing to check is to make sure that you've got enough positive and enough negative to go through and find clear signal to go through the Unmixing wizard. With beads it's not too difficult, it's very easy to find a clear positive and a clear negative. The last thing to check with these fluorescent controls is to make sure our negative is actually negative. So in this spectral plot to the right, we're only seeing what comes up in this positive gate. So if we drag this gate over to the negative population, we can check to make sure our negative is in fact negative and we don't have any contamination or carryover from the previous tube. and we didn't accidentally stain the whole sample. So that one looks clean, and let's check another one. Beautiful. So you'd have to go through and check every single tube to make sure that there's no contamination present in the sample. Okay, so I'm happy with all of these. I'm just going to double check that my viability is gated correctly and my unstained. We're just going to gate on our cells of interest, which is lymphocytes in this case. And then I'm going to click the next button to go through to the QC controls tab. And I'm going to click Similarity Matrix on the left here and View Similarity Index. So now we can make sure that every single dye in the panel is unique. We're looking for numbers either equal to or below 0.98. 0.98 is the absolute maximum of similarity that the Aurora can resolve. So we need all of our dyes to be 0.98 or below. And you can see that our highest number is 0.86. So all of our dyes are unique and we can go forward with unmixing. So I'm going to select live unmixing. Okay, our unmixing has finished. So now we're going to evaluate this unmixing. So we unmixed using all beads as our controls. So now we need to see what the single stained cells look like using this unmixing. As what we're trying to do is decide whether beads are sufficient for unmixing cells. If there's a spectral signature mismatch between the beads and the cells, if our beads weren't a good enough control, then the unmixing that we see with our single stained cells will have errors in it. So then we can change the control that we used from beads to cells and go forward with another iteration of the unmixing. So to check our unmixing, we're going to create N by N plots. So to start off with, I am going to just do a simple gate here on my cells of interest. I'll also do a singlet gate just to make sure we're not getting anything too terrible. We can't do live dead gating, of course, because these are single stained cells. So we'll just take it from single cells of interest. You can be a bit more picky here if you'd like. I'm just doing this for demonstration purposes. And then on the x-axis, we're going to set them all to the same fluorophore. So starting at the top of the list, and then we'll change the y-axis to the first one as well. Then we're going to duplicate this plot and change only the y-axis to the next one down the list. Duplicate again, and carry on down the list. Duplicate again. And then if we duplicate the whole row, we can carry on moving further and further down the list until you've got a plot that represents every single colour that's in the panel. So here I have one that I prepared earlier, and what we want to do once we've created this whole series of N by N plots is to save this as a worksheet template, as we're going to refer back to this in future protocols and future videos. So if we save this as a worksheet template, yes, here we go. So now I can refer back to this worksheet at a later date, and I won't have to recreate all of these plots from scratch. So what we're going to do is we've got our BUV 395 sample selected. So if we come to the Properties tab, we can change all of our plots simultaneously to BUV 395, and we can evaluate the unmixing of this control. So what I'm looking at is how the sample behaves in the x-axis with regards to the y-axis. So what I'm hoping to see is that the centre of the positive population lines up with the centre of the negative population. And as you can see, with all of these plots, everything is in a nice straight line, and the unmixing has worked really well. So I know that beads are a pretty decent control at this stage for my single stain cells. Okay, so let's check a different cell control, and I have an example of one where the unmixing using beads is not quite optimal. So let's change our x-axis to match the control that we have selected. Find it in the list, here we go. And then we need to again check that the centre of the positive matches the centre of the negative. And you can see that in most of these plots that it does match really well, but in a couple of them we can see that the positive population is skewed compared to the negative. And so the centre of the positive here sits slightly lower than the negative, and we can see that that is curving downwards. So the brighter we go, the more error that is present. So these beads were not optimal when it came to unmixing cells. So the next round we are going to select cells instead of beads. So you want to go through every single control in the list and check how the cells have unmixed using the beads. And if you see errors like this, then we know that we need to swap that control out for cells, as the beads were not optimal. And once you have decided for every single colour in the panel whether it should be on cells or on beads, we're then going to go back through the unmixing wizard and use that combination of cells and beads that you've decided on. Okay, so I've selected my combination of cells and beads that I've decided on. And now the thing to notice is that we do have to go back through and set new gates on all of the controls that we have changed to cells. So with the P1 gate, again we want to be specific to the cells of interest that are going to express the marker that we're looking for. So I'm just interested in lymphocytes here. And again, we have to go through all of those checking steps that we did with the beads to make sure that our signature peaks in the right place, has the correct signature, has nice tight populations in each channel, there's enough positive, there's enough negative, and the whole signature is clean, including our negative. And this is where it really becomes important to only gate on the highest fluorescent intensity particles in the plot, as we could gate on this whole broad positive peak, but then our signal in each channel would not be nice and tight, and the median fluorescence would be dragged down. So we would have a much smaller range of fluorescent intensities that we can unmix. So by keeping it right up at this top end, we're getting the nice tightest population we can and the greatest distance between positive and negative, meaning we can unmix a much wider range of brightnesses in our full stained sample, which is good. So once you've gone through and set all of your gates on the cell controls that we've added in, we can go through and live unmix to overwrite the previous unmixing that we did. Okay, and once our unmixing has finished, We then need to go back through and check all of our single stained cell controls again to make sure that the unmixing is looking better. So let's start off again with this one that already looked good before, but we'll just double check it using our n by n plots that we've already created. And yes, everything's looking good. So let's come back to one that didn't look so good. So let's change our x-axis to match the control. Here we go, and let's compare the positive to negative populations. And we're seeing nice straight lines, which is perfect. It's exactly what we want to see. So our unmixing has improved, which is great. So once I'm happy with the combination of beads and cells that I've got for my unmixing, and all of my cells presenting like this, where my positive population is unmixed correctly, I can then move forward with the next protocol.